We'll be studying climatology part 1. In the next video we will be studying climatology part 2. So in total we have for climatology two parts, part 1 and part 2. So let's start with today's session. So in this session what we are going to study, let's see in brief. So first we'll be studying about the latitudes, then we'll be studying what is the tilt of earth, then we will be studying why do we experience different seasons, and then what is summer solstice, what is winter solstice, and that is done. Then we will study about the greenhouse gases, what are greenhouse gases, and then next we'll study about the composition and structure of the atmosphere. Then we will move on to insolation and terrestrial radiation, and we'll be again studying next about the heating and cooling of the atmosphere. In that we most will see these words, like what do they mean, like convection, advection and conduction. And finally we'll be completing our lecture with the topic temperature. In that, the very important topic, that is temperature inversion, we'll be studying. Many times we can see questions from this topic, temperature inversion. So we'll be studying everything in detail, conceptually. Okay, so now let's start. So first we'll study what are longitudes and latitudes. For people who already know it, it will be a quick revision for them, and for people who don't know these things, then it will be, you'll get to know about these things in a very few minutes. Okay, so let's start. So first thing we know that what is equator. It's an imaginary line that divides earth into two halves, northern hemisphere and southern hemisphere. This will be your northern hemisphere, this will be a southern. So it's an imaginary line that divides earth into two halves, is known as equator. And there are some lines, if you could see here, let me just change a color. So if you could see these yellow lines, there are some lines which run parallel to these equators. Those are known as latitudes. Okay, so now let's see what is Tropic of Cancer, what is Tropic of Capricorn. So it's a line which runs parallel to equator at 23.5 degree. If it is in the northern hemisphere, it's known as Tropic of Cancer. If the same line is in the southern hemisphere, then we know it as Tropic of Capricorn. So the red line that you could see here, just a minute, yeah, this is the red line which you could see here. This is known as Tropic of Capricorn in the southern hemisphere, and the line in the northern hemisphere is known as Tropic of Cancer at 23.5 degree. Okay, and if the latitude is at 66.5 degree in the north, it is known as Arctic Circle, and if this latitude is at 66.5 degree south, it is known as Antarctic Circle. Okay, I hope this is clear to all of you. Now let's see what is a tropic. Just a minute, I'll erase these things. Okay, now let's see what is a tropical region, what is a temperate region. Okay, so the area between equator and Tropic of Cancer is known as tropic zone, and area between Tropic of Cancer and Arctic Circle is known as temperate zone. Why I'm telling you this is because in next when we start the main topics, we'll be able to see these things like tropical zone, temperate zone. So that's the reason I'm telling you this prior. Okay, now the same thing goes in the southern hemisphere. This is a tropic zone, and then this is a temperate zone. Okay, yeah, now this is one thing. Now let's see how is our earth tilted. If you could see this image, you can see that earth axis is tilted with respect to its orbital plane. Like, see here, this is a earth axis. What is the axis? Its axis is an imaginary line an object turns around. So this is a imaginary line around which our earth turns around. So this is the axis, and the earth axis is tilted with respect to its orbital plane. So if we take this as an orbital plane, it's tilted. It makes an angle of 66.5 degree. This is the reason why this tilt is the reason why we experience different seasons. If you could see here, say sun is in between. Okay, so earth's axis is tilted, right? So here if you could see, it's like a tilted, you can see that, right? So whenever it is on 21st June, summer, we can experience summer season in northern hemisphere, because sun rays are very there are huge amount of sun rays in on 21st June in northern hemisphere, and on 23rd September we experience spring. On 22nd December we experience summer solstice, winter solstice in northern hemisphere. We know that most of the continents are in northern hemisphere, like landmass is more in northern hemisphere. That's the reason we are considering a northern hemisphere. So if it is winter in northern hemisphere, we say it winter solstice. If it is summer in northern hemisphere, we say it summer solstice. So if you could see here, there is this line. So you can see winter is experienced in northern hemisphere, like this part is the northern hemisphere, right? So only this much sun rays, this much part experiences sun rays, like a, and the other part here, they do not experience a very heat, like a sharp sun rays. So that's the reason we experience winter in on 22nd December. Then on 21st March we experience a spring. So this is about like overview of what is summer solstice and winter solstice. We'll study in depth about these things in a part 2 of climatology. Okay, now let's move on to composition and structure of atmosphere. This is the most important thing. Like many exams, like especially if we see a competitive exams, we get a lot of questions from these topics. So now let's start with this topic. Just give me a minute. Yeah, composition and structure of atmosphere. So in the composition and structure of atmosphere, first we'll be studying what is the composition of atmosphere. See, in this chapter mainly this is chapter 8 of your NCERT. So in this chapter they have given mainly three things that are the composition of atmosphere. One, they have given gases. Second, they have given water vapor. Then third, they have given dust particle. So before going into this, one more thing which I would like to tell you is, we need to know what are greenhouse gases. Like we have heard, right, there is a greenhouse, we have heard this lot in the news as well. There is, because of greenhouse effect and we are experiencing global warming. So now let's see, what are greenhouse gases. Greenhouse gases are those gases which block the escape of heat radiation from earth but allow sun radiation. Like say this is the atmosphere. Okay, so now they allow sun radiation enter the earth's atmosphere, but when heat is radiated from earth, they do not allow them to go back in the atmosphere, like they just block it here. So when they block it here, we experience a heat, right? That's those gases which allow sun radiation but block the escape of heat radiation from earth are known as greenhouse gases. So I hope now this is clear to you, what are greenhouse gases. So let's study now about the composition. Let's come back and study about the composition of atmosphere. So first we'll study about the gases. We know that gases, we have carbon dioxide and then we have ozone. So before studying about the gases, let's study what is the percentage composition of gases in our atmosphere. I have done this small mnemonic because in most of the competitive exams they ask this question, like what is the composition. So you can say no AC neha. So it's like a mnemonic. So N in no AC neha, first N stands for nitrogen. Nitrogen is present in huge quantity in the atmosphere first. Then we can see oxygen. Then A stands for argon here. Then C stands for carbon dioxide, and here Ne stands for neon, and last finally Ha helium. H stands for helium. So this is a small thing you can remember, like a mnemonic, no AC Neha. If they ask you to arrange the order of a percentage composition of gases in the atmosphere, you can just remember this mnemonic and solve the question. So now let's come back here about for the gases, and let's see. First let's see about the carbon dioxide. Carbon dioxide is a greenhouse gas. Why? Because here we have seen all those gases which allows sun radiation but does not allow the escape of heat radiation from the earth are known as greenhouse gases. So carbon dioxide, that is a greenhouse gas. That means it allows the sun radiation but it does not allow a heat radiation to escape into the atmosphere, into the space, you could say. So see here, it acts like a greenhouse gas. So first thing they can ask you is like, is carbon dioxide a greenhouse gas? Yes, carbon dioxide is a greenhouse gas. Then next let's study about the ozone. What is ozone? See, ozone is another important component of atmosphere which is found between 10 and 50 kilometer above the earth's surface, and it acts as a filter and absorbs the UV rays radiating from the sun and prevents them from reaching the surface of the earth. So in UV rays, we have mainly three types of UV rays. One is UV means ultraviolet rays, A, B and C. Ozone, it stops only UVC rays. It allows UVA and B. They can ask you in the exam. One MCQ can be formed from here, one from here. So what they can ask is UVA and B allowed to enter Earth's atmosphere through ozone? Yes, it is allowed, but UVC is not allowed because ozone does not allow that. And one more thing you are supposed to remember is ozone is found between 10 to 50 kilometer. We will study about different layers, like a structure in the structure of the atmosphere part. Just remember, like if you could remember, it's okay, or else no problem. But it is found between 10 to 50 kilometer of the above the earth's surface. Okay, that's about the gases. Now let's move on to water vapor. So see, first thing we need to know is like water vapor. When we listen to water vapor, most of the we know that water vapor is a gas, but we feel sometimes that it's like liquid or something because of a word water. So first thing you need to know is water vapor is in a gaseous form. Okay, next thing you need to know is water vapor is a variable gas, that we know. Then next thing is water vapor is also a greenhouse gas. Many people do not know this because see, we do not know because it's not in news. Have you heard anywhere like water vapor is causing a global warming? The reason we have not heard about this is because water vapor does not have a long lifetime as compared to other greenhouse gases like carbon dioxide. So water vapor also, what it does is it allows incoming solar radiation, but it does not allow a escape of earth's radiation, escape the heat radiation from the earth. That's the reason water vapor is also a greenhouse gas. Okay, and it decreases with altitude in warm and wet tropics. Warm in the sense, here we have seen, right, about the earth. This tropic zone is known as warm region, and as we go towards the pole we see a cold region. This whole tropic is warm because there is sunlight present over this zone most of the time. So warm and wet, so water vapor. So let's come back to this thing, water vapor. In warm and wet tropics it may account for 4% of air by volume, while in dry and cold areas of desert and polar regions it may be less than 1% of the air. So here in these things, in these cold places, see, when we hear about the word desert, there are two types of desert. We should know that one is hot desert, one is cold desert. usually when we hear the word desert, we just get a thought of hot desert, but we should know that cold desert. What is a desert? Desert is a place where there is not much plants, or there is not much animals there. There is no flora and fauna present in particular place. That place is known as desert. So in this cold and dry desert areas in near the poles, the water vapor percentage is less than 1%, and near this tropic zone, this near the equator, the tropic zone, the water vapor account for 4% of the air by volume. That's one thing you need to know about the water vapor. And one more important thing you need to know about the water vapor is water vapor also decreases from the equator towards the pole. That's what, like the as you go towards the desert area, the water vapor content decreases. And yeah, one more thing is water vapor contributes to stability and instability in the air. So what is stability? You should note down that stability means no rain, instability means rain. I know this might sound like vice versa, but instability means rain, stability means no rain, or you can say like a drought. Yeah. So water vapor also contributes to stability and instability in the air. That's all about the water vapor. And now let's go to dust particles. See, dust particles are what? If you see in the environment, you could see that small particles which are flying in the air, like a smoke, or it can be some dust which is flying in the air. Those are dust particles. Okay, so these dust particles include like sea salts, fine soil, smoke, soot, ash, pollen, dust, and disintegrated particles of meteors. And dust particles are generally concentrated in the lower layers of the atmosphere. So if you see the environment, you could see some small particles flying in the lower layer of atmosphere compared to the upper layer of the atmosphere. And these dust particles are responsible for these dust particles act as a hygroscopic nuclei around which water vapor condenses to produce clouds. And these dust particles are mainly responsible for the formation of clouds. Okay, that's one thing you need to remember. And they're found in higher concentration in subtropical and temperate due to dry winds compared to equator. They might ask you a question here. Just let me erase this. Yeah, so dust particles are found in higher concentration in subtropical and temperate regions. What is subtropical region? Here, from 23.5 degree north till 30 degree is subtropical region. Here, 23.5 degrees south till 30 degrees south, this is also a subtropical region. So dust particles are mainly found in subtropical region and temperate region. What is temperate region? We know that, just give me a minute. Yeah, this region from Tropic of Cancer till Arctic Circle is known as temperate region. Okay, same applies to the southern hemisphere as well. Here, okay, so dust particles are found in high concentration in this temperate region and a subtropical region, same with southern hemisphere. This can be one more MCQs. Whether dust particles are found in higher concentration in equatorial region or tropical region? No. Why? The reason is here there are frequent rains. As a result, dust particles move upward and they come down in the form of, like when there is a rain, they come down. So they're not found in higher concentration near equator. Instead, they're found in higher concentration in subtropical and temperate regions. Usually these dust particles are concentrated in lower layer of atmosphere, but due to convectional air currents they may convectional air currents may transport them to greater heights as well. Okay, so this is all about the dust particles. So now let's move to the next concept, that is structure of atmosphere. This is like the most important topic because many times you get a question from this area, so you can get one MCQs from here. Okay, before we move into the structure of atmosphere, let's see what is the general view of the atmosphere. So we have divided our there is no division, like there is no line in the atmosphere, it's just our way of understanding atmosphere in this way. So we have divided the atmosphere into 5 parts. First one is troposphere, then stratosphere, mesosphere, thermosphere, exosphere. So um, troposphere is that area from ground till 10 kilometer above the surface of the earth. So this 10 kilometer is different towards the pole and different towards the equator. Why? See, this is the earth, you say. As you go, you're standing here on the earth, you go above, and say you're standing in near the equator, and once you reach 18 kilometer, then till there you'll find this troposphere. But say you're standing here on the pole, oh sorry, I have drawn like reverse. Say you're standing on the pole and you go just 8 kilometer and troposphere is done. Why is this difference? Near earth, near equator, the troposphere extends till 18 kilometer, but near pole, this is equator, but near pole it extends just till 8 kilometer. This is due to geoid shape of earth. So we know that earth is in this geoid shape, right, like this. So if you're here in the middle of the earth, see the distance from center till the pole and distance from center till the equator end. See, this is more, right? As a result, the gravity is less here, so the troposphere extends to a greater heights, and near pole the gravity is more. That's the reason the gravity pulls the air towards it and keeps it. So a troposphere extends till 8 kilometer. So we can draw it this way. So it's like this. Here it is 18 kilometer and here it is 8 kilometer. On an average we say it as a 10 kilometer. So I hope now you understood what is the extension of troposphere near equator and what is the extension of troposphere near the pole. Okay, and next thing you need to know about the troposphere is all the lightning and rain, whatever you see, that happens in the troposphere itself, like the clouds, lightning, weather, and all the activities you see, that happens in a troposphere, and we live here. Okay, and next what you're supposed to know is, yeah, one more thing is you need to know about this word called environmental lapse rate or normal lapse rate. What happens is, as you say you are on the earth here, right? So as you go above, then there is 1 degree Celsius decrease for every 165 meter. Say 165 meter you went above, there is on a ground it is say 30 degrees Celsius. Then you go 165 meter above, then there will be 29 degrees Celsius. So this decrease is known as environmental lapse rate or normal lapse rate. And temperature decreases with increase in altitude in troposphere. There is a variation of temperature in different layers of the atmosphere. In troposphere, the temperature decreases with increase in altitude. That's the other thing you need to know about the troposphere. So that's all about the troposphere. Now let's move to stratosphere. What is stratosphere? See, just give me a minute. Yeah, sorry for that. So stratosphere is a area between 10 and 50 kilometer above the earth's surface. So area between 10 and 50 kilometer above the, say you start moving in a vertical direction from today, and once you cross 10 kilometer from the surface of the earth until you reach 50 kilometer, that is known as stratosphere. And we can see whenever we are going in an aeroplane, we are in the stratosphere. So aeroplane are in a stratosphere, and ozone layer, which is ozone, which we spoke before, is also found in stratosphere. Why are aeroplanes moving in a stratosphere? The reason is there are no clouds present over here, and there is no vertical winds moving in stratosphere. In troposphere we can see a vertical winds moving and clouds present, but in if these clouds and vertical winds are moving, then it becomes very hard for aeroplane to find their direction. So they are moving in a stratosphere. So this one question can be asked for you. They can ask you like, aeroplane are found in stratosphere or troposphere, like where do they travel, like in which layer do they travel? Stratosphere, that's one thing, and ozone, that's also very important thing. Two MCQs can be formed here. So stratosphere means, first whenever there's a word stratosphere, you have to quickly remember the word aeroplane and the ozone, and it extends from 10 kilometer to 50 kilometer from the surface of the earth. And here the temperature increases with increase in height. So that's all about the stratosphere. Now let's move to mesosphere. Mesosphere, whenever there is a meteor, the meteor burns here because, yeah, there's a burn whenever there is a meteor that enters the meteoroid or a asteroid that enters the earth's atmosphere, they burn here. Most of the time they burn here. If they don't burn here completely, then they hit a earth and they form a crater, that we call it as crater lake, or that we call it as a crater. So that's about the this mesosphere. Here also the temperature decreases with increase in height. The general trend is the temperature should decrease with increase in height, but there are two exceptions. One is stratosphere, one is thermosphere. In thermosphere, temperature increases with increase in height, and in stratosphere also temperature increases with increase in height. So now this is about a mesosphere. Now let's move to thermosphere. Thermosphere is, it's an area from 80 kilometer till 700 kilometer from the surface of the earth. In that thermosphere we have again two parts. One is 80 to 400 kilometer, is known as ionosphere. And ionosphere, why? Because it contains electrically charged particles known as ions, and hence this layer is known as ionosphere. And here there is a temperature increase because of these ions. That's one thing. And this whole layer from 80 to 700 kilometer is known as thermosphere. And the main reason why you need to know here is this about this is radio waves reflected, radio waves are reflected from this layer, and we can find all the satellite, like whatever satellites we launch, they will be found in this layer, like in this range, like 80 to 700 kilometer. That's about thermosphere. Then next let's move to exosphere. Here temperature decreases with increase in height, and this is found from 700 to 10,000 kilometer, and this area is used by scientists for their work, and it's mostly unexplored. So this is about the structure of atmosphere. So once we are clear with this, so now let's move to next topic. Just a minute, we'll see what all topics we have covered. We'll mark them. Latitudes is covered, tilt of earth axis is covered. Why do we get seasons? We understood summer solstice, we understood winter solstice, we understood what is greenhouse gas, then we understood structure and composition of atmosphere. Now we will understand what is we have not yet understood this. We'll understand that and then we will take it here. Okay, now we will understand what is insolation and terrestrial radiation. Okay, so in chapter 9, this is a chapter 9. In chapter 9, that is solar radiation, heat balance and temperature, mainly we'll be going to see three topics. One is solar radiation, then we'll be studying about the temperature, and in that we'll be studying about the inversion of temperature as well. So these three topics. So first let's study about the, just a minute, we'll study about insolation and terrestrial radiation. What is insolation? What is terrestrial radiation? See, we know that we have a sun and it emits energy, right? The energy that is received by earth is known as incoming solar radiation. In short, we say it as insolation, like for also known as, we say aka, right? So in the same way, short form for short form for incoming solar radiation is insolation. First thing you need to know about that. So whenever you hear about the word insolation or solar radiation, it's the incoming, it's the energy received by earth from the sun, right? So here we have earth, and this energy what we receive is known as insolation. So now once the earth has received energy, it also has to emit back that energy, right? Once it is heated. So when the energy is emitted by the earth, that is known as terrestrial radiation. So terrestrial radiation is earth. Okay, now we understood about insolation and terrestrial radiation. So here you need to know that hotter body like sun emit short wavelength energy, just a minute, yeah, and cold bodies like earth emit long wavelength, okay, energy. So this is about the insolation and terrestrial radiation. There are different factors that cause variation in insolation, that is incoming solar radiation. Before studying about them, let's see about the words like we hear perihelion and aphelion. What is perihelion? Perihelion is a date when sun is nearer to earth, and that on 3rd Jan sun is nearest to earth, that is known as perihelion. And when sun is far away from the earth, that is known as aphelion, and that date is 4th July. So how you remember is see, p, if you observe here, p, the word comes here first, so that means it's near, and here it comes second, that means it's far, right? So far means aphelion, near means perihelion. So that's how you can, just like a easy way to remember it, or else you can remember it any way you feel to. So this is done. Now let's see about the factors that cause variation in the insolation. We studied insolation means incoming solar radiation. The energy received by the earth, right, is known as incoming solar radiation, is also known as insolation. So now let's see, there are different factors which cause variation in incoming solar radiation. The first one is rotation, then we have angle of inclination of sun rays, then we have length of a day, transparency of atmosphere, and then configuration of land in terms of its reliefs. So first let's see about the rotation. We know the fact that Earth's axis make an angle of 66.5 degree with the plane of its orbit around the sun and has a greater influence on the amount of insolation received at different altitudes. See here, we saw it already here. Earth's axis, this line makes an angle of 66.5 degree with the plane of its orbit round the sun and has a greater influence on amount of insolation received by different latitudes. So we know that when the light falls here, it receives a more energy compared to when it fall here, because it has to travel through the atmosphere and it scatters. So if you might have done this experiment in your childhood as well. Say there is a place here, and if you have a light directly falling at one particular point, then there are chances that sometimes paper burns as well because of that huge focus of sunlight. But if it is scattered, then the paper won't burn because the energy is distributed in that place. So the angle of second reason here, the angle of inclination of sun rays is one of the reason in insolation, variation in insolation. Okay, so that's done. Now let's see just a minute. Now let's see the transparency of atmosphere. The atmosphere is largely transparent to short wave solar radiation. We have seen here that solar radiation is a short wave because hot body emits short wavelength rays and cold body emits long wavelength. So atmosphere is transparent to short wave solar radiation, that is incoming solar radiation passes through the atmosphere before striking the earth's surface. Within the troposphere, water vapor, ozone and other gases absorb much of the near infrared radiation. So since the atmosphere is transparent to the insolation, passes through the atmosphere before striking the earth's surface. That's the transparency of atmosphere, which causes a variation in insolation. Then configuration of land in terms of its reliefs. Say you are on a place, there is a mountain and there is like a plain land. So if you could see, there are at some mountains there is a ice cap here, like a white one, that is due to land reliefs, and these land reliefs cause variation in insolation cause variations in insolation. And one more thing you need to remember is maximum insolation is seen in subtropical desert because there are no clouds present in subtropical desert. This can be asked as one MCQ. Like maximum insolation is seen in subtropical desert. Then at the same latitude, continent insolation is more than ocean because oceans are not transparent compared to because oceans are not transparent, right? Because they have water, they don't allow sunlight enter into the ocean to a greater depth. That's the reason continent receives more insolation compared to oceans, and equator receives less insolation than tropics, because at equator we could find the clouds. That's one more MCQ which could be formed. Okay, so this is about the solar radiation and terrestrial radiation. Now let's see about the heating and cooling of the atmosphere. Okay, so in heating and cooling of the atmosphere, we need to know mainly about the three terms which most of us get confused. So first, let's see what is conduction. Say you have a pan which you are using for cooking, and this pan has, I know I'm not that great at drawing, just let me try if I could draw something. Say this pan has one stick to hold. So when you, if you had experienced this, when you hold here, the as the pan gets heated, after some time even the stick also get heated, right? So this is conduction. Conduction is what? Transfer of heat between two bodies is called conduction. There is transfer of heat between these two bodies, right? This is a first one and this is a body 1, this is body 2. There is a transfer of heat between two bodies till they attain a same temperature, is known as conduction. So here I have written it also. Conduction means no, just a minute. Conduction is what? Basically conduction is a, just a minute. Yeah, so conduction is what? Basically conduction is transfer of heat from one body to another body is known as a conduction, and this continues till two conditions, any of these two conditions are met. First one, there should be a break in the contact break, or second condition is when both body attain same temperature. If they attain same temperature, then the process stops. Attain same temperature. So this is about a conduction. So now let's move to the word. Yeah, one more thing before we go into this thing. Next topic is this conduction is very important for in heating the lower layers of the atmosphere. See, we know that this is the earth and we get a solar radiation, that is insolation from sun, and because of conduction we get a solar radiation, and once earth is heated by solar radiation, earth also emits back some radiation which is known as terrestrial radiation. Because of terrestrial radiation, earth is getting heated. You should know that solar radiation is not heating earth. Radiation is not heating earth heating. I'll just write it here. Earth is heated, I mean temperature is warm in our atmosphere because of earth. Like we are able to experience the heat because of earth radiation is heating, is responsible by earth radiation, not solar radiation. So in that process conduction plays an important role, because see, when earth radiates its energy back, I mean when earth emits its radiation, so this down part will get heated. How? But upper part will be a cold area, right? So how will this get heated? This is because of conduction. Okay, now conduction is done. Now let's move to the next topic, that is convection. What is convection? Convection is a transfer of heat in a vertical heat, like this is a process of vertical heating of the atmosphere. Say atmosphere is getting vertically heated. That is known as convection. And the convection transfer of energy is confirmed only till troposphere, and after troposphere the convection is not working. So troposphere only due to, this is due to pressure. Okay, this is about convection. What is advection? Advection is transfer of heat through horizontal movement of air. Like, say there is very much of heat here at this point 1 and it's cold here in point 2. When advection happens, then the heat, just a minute, yeah, when the advection happens, then there is a travel of heat from one place to another. So that is known as advection. Northern Indian experience a loo during summer season. That's a local wind called loo during summer season, and this is a outcome of advection process. That is a transfer of heat through horizontal movement of air. Okay, this is about these three words: convection, conduction, and advection. So this is done. Now let's see about one more important topic, that is factors controlling a temperature distribution on earth. What are the factors that control temperature distribution? Then first one is latitude, then we'll study about altitude, and then distance from sea, air mass circulation, and presence of warm and cold ocean currents, local aspects like pollution and height of a place. So if the latitude increases, then temperature decreases, and if latitude decreases, then temperature increases. What does this mean? See, say this is earth, sorry for this drawing, say this is earth. Okay, so we know that equator is at 0 degree latitude. So if and as we go above, the latitude increases. Say it is 23.5 degree north, then we have 66.5 degree north, right? Like that it increases. So if this increases, then temperature decreases, because we know that near poles it's ice, right? So as we increase the latitude, temperature decreases, and if we decrease the latitude, like if we come from 23.5 degree till 0 degree, that is we decrease the latitude, then temperature increases, and we know that equator experiences the heat compared to poles. So this is about the latitude. Next, let's study about the altitude. So say you are on a land and there is one mountain over here, there are trees here, and you are standing here. So if altitude increases, temperature decreases. Say you start climbing a mountain top, and once you are at the top of the mountain here, the temperature is cold, and if you come back again on the land here, then the temperature is high. So when you increase altitude, temperature decreases, and if you decrease altitude, that is if you're on the land, then temperature increases. So this is about the altitude. Then next, let's see what is the distance from sea. How does distance from sea causes variation in temperature distribution? So say this is a earth, right? And no, let's take it this way. Like, see, we know this is a Indian coastal borders. So if you are at near to the sea, say you are in Mumbai, then you don't experience the extreme temperature. Like it won't be like 50 degrees in summer and like minus 10 degrees in winter. It's a moderate temperature. Like most of the time you'll be experiencing somewhere around 25 to 35 degrees Celsius throughout the year on an average. So whenever you're near sea, distance from the sea decreases. That means you're near sea, then you experience a moderate temperature, and if you're away from the sea, say Delhi, you are in Delhi, then you experience a extreme temperature. That's how a distance from sea affects a temperature distribution. Next, let's see about the air mass. What is air mass? Air mass is a place where a, say you are on standing here at a place, and here the temperature of the air is same throughout, that is called as a particular air mass. Temperature and pressure that place, that air mass is, that is called as air mass. If there is a warm air mass, then temperature increases, and if there is a cold air mass, then temperature decreases. So this is about the air mass. Next, let's see how ocean current affects a distribution of temperature. Like how does a temperature is distributed on the basis of ocean current. So if there is a warm ocean current, then near places temperature will increase. If there's a cold ocean current, near places temperature will decrease. Okay, we'll study about the ocean currents in oceanology. Once we start oceanology, then we'll get to know about more about the ocean currents. Just know that warm ocean currents increase a temperature in nearby places, and cold ocean currents decrease a temperature in nearby places. So this is all about the factors controlling temperature distribution. Everything like here can be formed like in MCQ. They can ask, like, if you increase the latitude, will temperature increase or decrease? Like if altitude is increased, what is the effect? How is distance from sea increasing the temperature or decreasing the temperature? All these things can be like forming one MCQ. So this is very important. Just know, like, see, now I have explained you how is this causing, right? So just know, whenever you given in the exam, it's easy to answer for you. Next, let's go to temperature inversion, the last topic and very important topic. You can expect questions from here. Before going to that, let's study what is the word isotherm. Isotherm is a line joining the places having the same temperature. Okay, now let's start with temperature inversion. So if there is a temperature inversion, what is temperature inversion? Before studying about temperature inversion, let's see what is a normal condition. When it's a normal, so warm air is down, because we know that earth is a reason why we are feeling the heat. It's not sun. You should always remember that we are experiencing the heat not because of sun, it's because of the earth's radiation we are experiencing the warmth. Okay, so warm air is down and cold air is above. This is like normal condition. But what happens in temperature inversion is, if cold air is down, I mean near to the surface of the earth, and warm air is above, that is known as temperature inversion. So if this temperature inversion needs to happen, there should be three conditions met. The first condition is there should be a long winter nights. The second condition is the sky should be clear, and the third condition is there should be a calm air. And if these three conditions are met, then temperature inversion happens. And this temperature inversion is very important for the formation of fog, dew. What is fog? Like you might have seen in the winter mornings, right? There is you feel like clouds are on the earth. That's what a fog. Dew is what, there you can see a tiny droplets of water on the leaves in the morning. That is dew. Okay, if these things need to be formed, then temperature inversion is must. Okay, and they can ask you in the exam, like one MCQ can be formed here. What are the conditions for temperature inversion? Long winter night, clear sky, calm air. Why these things? Let's see in brief. Okay, see, this normal condition should turn to temperature inversion condition. This is possible when we have a long winter nights. Long winter nights, what happen? Earth radiates its all of its heat energy in the night, and it becomes cold. So first condition, it should be long winter night. Second one, it should be clear sky. Why clear sky? Say if you have a clouds here, then it does not allow a warm air to escape, right? So you should have a clear sky, there should not be clouds. And calm air, say if there is a wind moving, then there are chances that a place has a warm air and that occupies this cold air region. So you should have a calm air. So these three conditions should be met for temperature inversion. And next, last thing we will study is air drainage. Before studying about air drainage, you should know that polar areas temperature inversion is common throughout the year. You can see this condition, that is cold air is on the surface and warm air is accumulated above a cold air. Is this condition is seen in polar areas throughout the year. They can ask you like one MCQ is does polar area experience temperature inversion throughout the year? Yes, they do experience temperature inversion is common throughout the year. And temperature inversion promotes stability, that is no rainfall in the lower layers of the atmosphere. Just remember that if this condition is there, then no rainfall. We'll study about how do we get a rainfall, what are the different conditions should be met for a rainfall to happen in our climatology part 2. Just know that if there is this temperature inversion condition, then there's no rainfall. Now let's see the last topic, that is air drainage. Temperature inversion takes place in hills and mountains due to air drainage. Okay, so what is air drainage? See, you have a mountains here, and this area is called as valley area. Okay, right, we know. So what happens is, when there is, whenever the, say in the night, okay, these mountains start emitting their heat, and they, just a minute, give me a minute, I'm sorry for that. Okay, so what here is, see, when uh, mountains, they are heated, right, they are a land, right, basically, like they are rocks. When they are heated in the morning, they need to emit the energy that they received. So when they emit, like they emit the radiations back into the atmosphere, like the terrestrial radiation happens, then the the upper part becomes hot, and these things, the cold air which is heavy, it settles down, and this is known as air drainage. Like temperature inversion takes place in hills and mountains due to air drainage. So the cold air drains into the valley, like down the valley here, and the hot air goes above, it drains, and so it forms a cold. So this is about air drainage. So I hope this is also clear to you now. So let's come back and see what all we have completed till now. So we completed insolation, terrestrial radiation, heating and cooling of atmosphere. We studied about conduction, advection, convection. Then we studied about temperature inversion. So this is about a climatology part 1. In climatology part 2, we will see about other things like El Nino, La Nina, atmospheric circulation, and cyclones, what is air mass, what are fronts, then the forces affecting speed and direction of wind, and many more topics. Okay, and we'll complete a climatology in total. Okay, thank you.